Hello, and in this video we're going to be looking at invariant lines. So I'm going to title that Invariant Lines. And the distinction I showed in the last video, but I'm going to re-show that now. So if I have a line in my xy plane, and I apply, or in my xyz plane, let's say, I'm going to consider xy first. And I have points on this line. I'm just saying one point at the moment. Then this point, assuming that this black line is an invariant line, this point could move up to here. However, it doesn't have to stay where it is. It is not an invariant point, but it is on an invariant line, therefore it will move to another point on that line. That's the key distinction. Okay, and now we're going to start trying to find invariant lines. So, our first example. 2, 0, 1, minus 3 is our transformation, and we're multiplying that by x, mx plus c. Now, x is normal, this is x, and y is mx plus c, that's just a line. So that's what we're doing. And that will go to x prime, y prime, where y prime is equal to m times x prime plus c. And yeah, that works. Okay, then we're going to multiply this out, so we're going to get that 2x is equal to x prime. Okay, and we're going to get x minus 3 mx plus c is equal to y prime. Now we're going to use this fact that we have up here, and we're going to sub it in down here. So we're going to have that x minus 3mx minus 3c is equal to m times x prime, so 2mx plus c. All good so far. And what this gives us is that we can now arrange our terms. So we can have, let's get x's on the right. Okay, so we're going to get 0 is equal to x. We'll get 5m x's and minus 1. So 5m minus 1 plus 4c. Now, for this to be true, x could be anything, let's say. This must equal 0, and this other section must equal 0. So 5m minus 1 equals 0, therefore m is 1/5. The gradient of the line will be 1/5. And from the other thing, we have that c is equal to 0, because 4c is equal to 0, therefore c must be equal to 0. So therefore the invariant line is y equals 1/5 x, because c is 0 and the gradient is 1/5. Okay? That's our first example. Second example we're dealing with is 2 minus 1 minus 3 naught. And we're going to multiply that by x mx plus c. That will be equal to x prime y prime. All the same as last time so far. So multiplying this out, we get that 2x minus mx plus c in brackets is equal to x prime. And therefore, also we have, that minus 3x is equal to y prime. So minus 3x is equal to m times 2x minus mx minus c plus c. Okay? Now we're going to do some multiplying out the brackets first. Minus 3x is equal to 2mx minus m squared x minus mc plus c. And then we're going to move everything over to the left-hand side. So we're going to get that 0 is equal to m squared x times, yeah, I would write out the x first, because then you can piece it up together much more nicely. X times m squared minus m, rub that out, minus m plus minus 3. Yes, so we got m squared. I've made a mistake. Where have I made a mistake? So m squared moves over, and we have a minus m here. Why do we have... they're connected to the c, sorry. I'm being stupid. Minus 2mc minus 3. And then we will have m minus 1 times c. Okay? Now remember, both of these must be equal to 0. I'm going to attend to this one first, and I'll explain why in a moment. So for this to be equal to 0, m squared minus 2m minus 3 must equal 0. And that means factorising, we get that m minus 3 m plus 1 is equal to 0. Therefore, m is equal to 3, or m is equal to minus 1. Okay? So, remember those two values. If we look at our other expression, we either get that m is equal to 1, or that c is equal to 0. One of those two, because this term must equal 0. But for the other term to equal 0, because we need an AND case, we need both of them terms to be equal 0. If m is 1, then this whole thing here is not equal to 0. So that's a problem. So we can't have m equal to 1. So therefore, we must have m equal 3 and c equals 0, or m equals minus 1 and c equals 0. Therefore, our invariant lines are y equal 3x and y equals 3x and y equals minus x. Okay. Next example. We're going to deal with is, I'm just trying to find my next example. Aha, got it. So 3, 0, 0, 3 times x mx plus c is equal to x prime y prime. Therefore, you get that 3x is equal to x prime, and 3mx plus c is equal to y prime, which is equal to mx prime plus c. Now substitute in for x prime. So 3mx plus 3c is equal to 3mx plus c. Therefore, you get that 2c is equal to 0. Therefore, c is equal to 0. Therefore, because these m's cancel out, it doesn't actually matter what value m is. The only thing that matters is that c must be equal to 0. So therefore, y equals mx for all m belonging to the real numbers are our set of invariant lines. Thank you for attending this video. I know it was rather long, but thank you for bearing with me this far, and hopefully I can give you more exciting content in the future.